slope. So not ski slopes, although it is looking kind of like that outside, but just slope of a line. That's what we're talking about. Slope is one of those concepts that comes back up in really each math that we see. It has something to do with it. So in geometry, we're going to be using it to tell whether lines are parallel or perpendicular, because we're talking about parallel lines right now. But we see it again in Algebra 2, and then, in fact, it is the basis of calculus, is in the concept of instantaneous slope. So today we're just going to cover the basics of slope that you've seen in pre-algebra, Algebra 1, and just remind us what it is and how to find it. So these first several statements, if you would like to write them down in your notes, you can. If it's something that you're like, I did not remember that, then probably it's a good idea for you to write it down. Most of this is just jogging your memory on what we know about a slope. Okay, so the first one we've got slope is the fraction blank over blank, so it is the fraction rise over run, which just means if we're looking at a line, we're going from one point to the next, and we're looking at how it goes up and over from one point to the next, the rise over run. The variable that we use for slope is m. Positive slope goes up from left to right, or looks like this. We always read a graph from left to right, just like you read a sentence from left to right. So if it's going up from left to right, it is a positive slope. The slope-intercept form of a line, that is usually what we take away from Algebra 1, is that y equals mx plus b, where m, we just said, is the variable for slope, and then b is your y-intercept, because that would mean that x is 0, so if we plug in 0 for x, you'll end up with y equals b. And then x and y represent every single ordered pair on that line. That makes it a true equation. Our negative slope goes down from left to right, so it's going to look something like that. For 6, we've got the point where the line crosses the y-axis, which I really already answered that. Our b variable over there is the y-intercept. We've got the slope of a vertical line. So vertical being up and down, the slope is undefined. That might not have been something that you remember. And then the slope of a horizontal line is 0. So one of the ways that I have students remember this, if you have trouble keeping those straightened out, the difference between vertical being undefined and horizontal having a slope of 0, we'll look at that more in a second. But if you're thinking about skiing, you can ski up a hill. So that would be a positive slope. You can ski down a hill, and that would be a negative slope. You can ski on a flat surface. Oh, my hand's kind of close. You can ski on a flat surface, but it's 0 fun, so it's slope 0. But once you're here, now you are not skiing anymore. That's just called falling. So that's why your vertical line is going to be undefined. It does not have a slope anymore. You're not skiing, you're just falling. And then our last one, our slope refers to the what of a line. Oh, I think we're missing something. In a real-world situation. So in a real-world situation, it refers to the rate of change, which is really important if we are looking at a real-world situation. Maybe we're looking at a bank account, and so as the y-axis, if it's talking about money, then slope would be describing how that money changed over time. So you're either gaining or losing money in that bank account. Okay, so if you need to, you can pause that and write down any of those things that you feel like are necessary to add to your notes. Looking at some graphs. Oh wait, let's look at these graphs first. Okay, so telling slope from a graph. First, we want to pick out 2 points that I know the ordered pairs of. So not choosing, I think this is at 1.6, something like that, but actually knowing, okay, I know that it crosses here at 0, 0, and it also crosses at 1, 2. So you don't necessarily have to write them like that, but just knowing I can tell where these cross so that I can count my rise over run. And if I have a graph, I can tell where they cross. I'm good with that. We can count. So for these 2 points, I would say, okay, my slope goes up 2 and to the right 1. Anytime we're looking at a slope and we go to the left or down, those are negative directions. So if I'm going up, that's a +2. To the right, it's a +1. So you might be wondering, so we got 2/1, which is 2. You might be wondering, well, what if I went from the point on the right to the point on the left? Not a big deal, we can do that. But if I go from the point on the right to the point on the left, now I have to go down 2, and I have to go to the left one. Kind of ran out of space here. So it would be down is a negative direction and left is a negative direction, so it still ends up being a +2. Okay, so it doesn't matter if we go left or right, up or down, really, as long as we're going from one point to the next, and anytime we go left or down, it gets a negative number. Okay, so second one, I'm going to go ahead and give you points here. We've got -3, 1. And then it is also crossing here at -2, -2. Okay, so I'm going to go ahead and give you this part of it down and over. See if you can tell what that slope would be. I'll give you a second. Okay, so to go from my y value of 1 down to a -2, I dropped 3. Where you can count 1, 2, 3, and then I went to the right one. So down was a negative direction, over was a positive, and we end up with a slope of -3. We can always check with the sign thing if we're confused there. Always check at the end to make sure, okay, I know that slope should have been negative because from left to right it was going down. Same thing with the first one. I knew that the slope should be positive because it was going up from left to right. Okay, so what if our graphs look more like this? So we just talked about the difference between our vertical and horizontal line slopes, but just to clarify why we know that this would be true, that a vertical has a slope of undefined and a horizontal has a slope of 0. Say we were to do the same thing. If I chose 2 points, so say here we're looking at -3, 3, and -3, -2, and it doesn't matter which 2 points, because notice, no matter what points I choose on this line, my x values are always going to be -3. So that means that my rise, it could be different depending on which 2 points I pick. For this one, my rise is 5 or a -5, doesn't really matter. But my run is always going to be 0 because to change from -3 to -3, I didn't go anywhere left or right. So that's why a slope ends up being undefined, because I'm dividing by 0. And I cannot divide by 0. That's why it ends up being undefined. Similarly, for horizontal lines, if I'm choosing 2 points, see we've got the point -1, 2, and the point 4, 2, and it's not going to matter which 2 I choose because either way, the rise will be 0. I did not go up or down. And then my run, I could either go to the right or left, doesn't matter. I didn't mean to make those both 5s, but anywho, doesn't matter how far they are apart because anything 0 divided by a number is always 0. Okay, so that's graphically. Then reminding us if we have the 2 points, now if they're pretty close together, we could graph them on a coordinate plane and then count our up and over, and that works just fine, but sometimes our numbers are larger. We see that with distance and midpoint, where some of us can get away with counting for a little while, but then you have bigger numbers and you're not able to use your counting strategy. So if we're finding the slope of a line, a lot of us probably remember the slope formula, which really is just giving us rise over run, but the slope formula says that we're going to subtract our y's, so we've got a y2 minus y1 over x2 minus x1. So that is the slope formula. If we didn't remember that, definitely write that one down. Let's look at a few of these together. So we've got our 2 points. We're subtracting the y's on top. It does not matter which y you start with as long as you use the same point first both times. So just like the distance formula. So if I start with my 1 and I have 1 minus a -8, then I have to start back again with this same point and do 2 minus a -1. So we end up with a +9 and a +3 for a positive slope of 3. And if we want to, we could visualize where these would be at on a graph just to confirm to ourselves, yeah, it should have a positive slope because it went from -1, -8 to 1. Easy to do. Okay, let's try one more. Again, I can start with either point. So if I start with the 4, 1, and I do 1 minus a -3, in the denominator we'll have to do 4 minus 0. Go back to that same point. End up with a slope of 1. Which so far, we haven't had fractions so far in our answers. Remember, if I'm saying 3, there's technically a 1 in the denominator, so if I was using that slope, it would go up 3 and over 1. This would go up 1 and over 1. Okay, and that is the gist. Okay, so the last thing that we're going to do, I want you to pause it and see if you can determine the slope of each one of these lines. So you've got 1 and 2, you've got the equation of the line, trying to determine what the slope is, and then the last one is through the 2 points. Okay, so pause the video, and then I'm going to go over it, but try them for yourself, and then confirm. Okay, so for number 1, it is already in slope-intercept form. Remember that y equals mx plus b, so I have the slope right there, where I know the slope is going to be equal to 2. That's all there was to that one. But for number 2, even though I have the equation of the line, it's not in slope-intercept form. So I do need to get it in that form to know what the m is. So that means I'm solving for y. So to get y by itself, just like I would if I was solving for an x and could get all the numbers on one side. So in order to get that y by itself, I need to add 4 to both sides. So I'm adding 4 here. And then I'm dividing everything by 3. 6 divided by 3 is 2. So I do have to divide everything by 3. I'm not allowed to just divide some of the things by 3. Everything gets divided by 3. So then in the end, I have it in slope-intercept form, just like the first one. And now we can see that our slope is 5/3. One of my favorite things about slope is that it being a fraction is not a bad thing. A lot of times fractions make things more difficult, more complicated, and sometimes they do for slope, but typically it doesn't because we've got that rise over run. It's okay that it's a fraction. Okay, and then last one. Oh, I think this might be exactly like the first one that we did. It definitely is. Well, hopefully you got it this time. I'll do it the other way this time. That if we start with our -8, we got -8 minus 1 over our -1 minus 2. You still end up with